Okay. Yes, Ritubroto, you require 3 loops. Yes, you have to use nested loops. Let's see what does a nested loops look like. Let's see how to actually work with this thing. So, can everybody see my screen?
Yes, sir.
Yes, sir.
Okay. So your problems look something like this. This is the one, right? We're talking about this loop. I believe so you're looking for this problem, right? So I require my header files. I should do it. H. I should include. So I require combinations of 1, 2, 3. So let's see something like this. I require 3 numbers. So I have got int fno. For fno, I require a SNO, I require a 3NO. So my first number, first, third. Okay. So for so my first loop will generate all my numbers 1, 2, 3, right? And my second number will actually generate also 1, 2, 3. Third number will also generate 1, 2, 3. So 1 less than equals to 3. So this is 1 plus plus. So my fourth number, second number will be 4, 7 equals to 1. 7 less than equals to 3. 7 plus plus. Right. For my TNO will be 1. TNO less than equals to 3. TNO plus plus. So I've generated my 3 numbers. So now I require to basically print them. Printf percentage d comma percentage d comma So let's see what this looks like actually. GCC. This looks like something like this. So this gives me a last line input. So can I have something like this? So this is what you see as a nested loop. This looks like a nested loop, right?
Sir, is the digit repetition is allowed?
Okay, now comes the fun parts. Okay, I'll take up one query at a time. So this is one of your queries, right? So are we allowed to have multiple digits? So this can be another problem. So the problem can be restated something like they generate all the combinations of 1, 2, 3, where no two numbers are actually same, right? So that is another problem. Okay, so we'll go with that problem also. But let's think of this thing. Can we do this with another set of a loop? So can we do this with let's take, for example, I want to work this out with a loop, right? So if I were to work with a while loop, my number, so I have to initialize my number right now. So FNO will be a 1, SNO will be a 1, TNO will be a 1, right? So while FNO is less than equals to 3, so my while SNO is less than equal to 3, so there will be another while TNO is less than equal to 3, right? Now so I print my printf. So this again goes over there. But then right now, if I actually do something like this, what will happen? If I actually keep this only to this thing, what will happen? Can anybody tell me what will happen?
Sir, it will be an infinite loop.
Infinite loop and only one
It
will
will be
be
infinite
repeated.
loop and all will be 1, 1, 1.
Exactly. So let's say I want to basically break up this loop first. So plus plus. Now what will happen? So I'm just increasing my t now. So what will happen? So what will happen?
So it will be 1, 1, 1, 1, 1, 2 and 1, 1, 3.
But sir, the
And-
program will not end. Like it will be,
Yes,
it will
sir.
be going
The
on.
program will be also infinite.
Are you sure?
But only three numbers will be printed, but the program will not stop. Right?
No, sir. Actually, after TNO becomes more than T, then it won't be printed anymore. Then
What-
the
but-
innermost while won't be operated.
My innermost while will not be operated, but what will happen actually? I'm asking for what is going to happen.
Sir, the program will not end, but after 111, 112, and 113, nothing will be printed.
Fine. Right. So I require a SNO plus plus. Now my second loop will actually end, right? My second inner loop will end. And if I give my this thing, FNO plus plus, this one will end. Now what will happen? Will it generate all my numbers? Will it generate all my numbers? Let's see what will actually generate. Since all of you are confused, let's see what will actually generate. Okay. So it will generate only this number, this amount of numbers. So what do I require to do? What do you require to do? I require to basically, before getting into this loop, I require to initialize my SNO again to be a 1. And when I get into my 30, I'll again initialize to be a 1. So what is going to happen is that when this loop actually starts, when my line number 25 loop starts again, right, it's going to TNO is going to initialize with 1. So if this becomes a less than equal to 3, so my inner loop of this part, so line number 28 to, so my loop of while loop of line number 20 is going to work. Right, so let's see right now what's going to this going to give. So you can see that basically there's a slight difference between working with the while loops and working with the for loops. So my lines of code actually basically decreases, but then while loops I've got a much more advantages, some other advantages also. Like I can do a lot. There is another sort of a loop over there, which we say to be as a
Sir,
yes.
so do we have to initialize SNO, FNO twice? I mean, in 24 line and 27 line.
Line number 24.
24.
Okay, I do not
Do
do
you
this.
have to write
And
it?
line number 27. Then tell me technically what is going to happen. Let's see what happens actually. Best thing is basically, let's see what's going to happen. So in no way you're going to basically destroy your machine. It's going to happen only this thing. What can I be telling you? Your output is only this thing. What?
But we are initializing it at first.
Yeah, okay. So let's say for this line number 28 to 29, 29 to 32, right? So TNO is less than 3, right?
Yes.
The one, so TNO becomes 3 right now. So it prints it, right? And it comes out. Now TNO remains to be as a 3. So in no way, when it's between SNO, right? What my after when my SNO becomes 2, what is going to happen when it comes to the line number 28? TNO remains to be as a 4 because TNO has been increased to a 4 because it has come to 4. It's been the loop has come out, so my condition has failed. So TNO 4 is less than equal to 3. I mean, so 4 is less than. No way my line number 28 to 32 is going to work because my TNO remains as 3 again. Okay, so I have to reinitialize my TNO again. So that is where my trick comes in over here. That is where my trick comes in over here. But then you can see if I actually since I have given SNO and TNO is basically not to be a 3 and I'm still increasing it, it does not become, my loop becomes finite. So this does not become infinite as if I had not initialized this thing. Right? If I had not basically increased my SNO or increased my FNO, right? So what would it have given me? It would have given me infinite loop. But since I'm increasing it, while I'm increasing it and I'm not basically initializing my 3 TNO with the initializing with my, as in my line number 27 or line number 24, if I'm not initializing with my line number 23 with the 1, my line number 20, this part won't work. Because due to this part, TNO has been increased. This has already, TNO has already become a 4. And since line number 27 has not been initialized, so if this thing has been not there, so my TNO remains to be a 4.
Okay, got it.
Okay.
Okay.
Any question here? Okay. While actually basically getting to this part, I had actually forgotten about one other loop. So this is what we say as a do-while loop. Do-while. So my FNO is less than equals to 3. So my initialization, this one will remain as it is. Right. So the difference between this while, the previous while, and this while loop and a do while loop is that even if my condition actually fails, it's going to basically start off from the beginning. Right? It's going to do something, and then it's going to do the checking. Right. So I'll actually show you what's going to happen. I'm going to work with SNO. So while SNO is less than equals to 3. I'm sorry, this will be also do while. Do while SNO is less than equals to 3. With this, please do while. After your while, this is the only place for the after your while there will be a semicolon. Okay, this is the only place where after a condition I can have give a basically a semicolon.
Sir, it will be only in do while and nowhere else.
No, it will not be anywhere else.
Okay.
Only be only. So that's equals to 3. Right. So this one will printf. So let's get this part of it. Let's copy this part. Okay, this one will be a while. I'm actually increasing this number, then plus. And then SNO plus. Yes. Okay. So let's see what happens. Answer. What is the problem? Okay, I think I got it right. So you can see one difference over here. See the numbers which are actually coming up. Can you please see the numbers? Can you please see the numbers? See the change in the numbers. What is the anomaly of this problem? What is actually happening?
Sir,
Sir,
the
the do
increment
while loop.
function is applied after the before the condition is checked.
So what is the effect?
So actually, even if SNO is becoming 4, then also 1, 2, and 4 is getting printed because while is checked after at the last.
Yes, yes. So for the do while, the negative attribute is that it will your system will actually run at least once, at least once. So if I had, so let's say the difference between, let's see this thing. What the difference if I actually give over here percentage t. So let's say I give a 3 over here, and I give a 3 over here, and I give a 3 over here, right? And I give a 3 over here, and I give a 3 over here, and I give a 3 over here. Right. So you will see that for my first while loop, it's not going to work at all. So let's see if I give something like this. See. Okay, but this one will work because this is actually a less than, so 3 is less than equal to 3, right? So let's give this a 4 actually. The fun part will actually start away if you actually give a 4. Yeah, see, it's not going to work. But even if I give this one as a 4, this one as a 4, the C, at least it will run once. At least it will run once for your second while loop, for do while condition. So one of the reasons is that it's going to do your work first and then do your checking. While in the first one, your it does the checking and then it does the work. Okay. Any questions here between a while and a do while? Any questions? So there are no questions. Have I been clear about it actually? If there are any questions, please ask. Because there are basically there can be many scenarios where, so the thing is that you have to understand what the difference between a while and a do while. So in a do while, the work will be the work will be done at least once. While in a while, the work, if the condition fails, in a do while, if the condition fails, still it will do at least once. But in a while, if the condition fails, it will not do at all. Okay. But then let's check for basically this one is still not completed. So this problem is still not completed.
Sir, in a do while loop,
Yeah.
if the while condition is satisfied, the control goes back to do.
Yeah, it control goes back to true.
Okay.
Okay. So similar to over here also, my TNO, I'll initialize to 1, and my SNO, I'll initialize to 1. Actually, I'm right or wrong? SNO plus plus. Yeah. Okay, what was the problem? TNO. Sorry. Yeah. Okay. So before I actually go to the line number 45, before I get into that do while loop, I initialize it with 1. Okay. So technically, actually, then for this case, this is actually not no more required. This thing is no more required actually. I'll be just wasting my time with another initialization. Because when it gets into the SNO, it will actually basically get into a one thing. Similar to actually this thing also, this is also not required. This part. Because once any question?
No, sir.
Okay, then yes. Somebody's trying to enter or something like that. I just advise that please do not write anything in your chats. Okay, the only reason is that I'm actually not looking at the chats, so I prefer that if you actually speak out. Okay, so even if you actually basically go on typing, you can go on typing. And when I actually see the chat, then that chat might not be no more relevant actually to the problem at that time. Okay, so there was one question. So I'll just keep this part. Okay, so let me just see this thing. So 1. So let's remove this thing. So the technically basically now I'll start playing with the system, right? So the first query, there was one query. If I do not want any repetitions, right? Then what I was supposed to do? So I don't require any repetitions. I'm not looking for any repetitions.
Sir, then before printf statement, we will put an if there.
Repetitions. So what will my condition look like? What will my condition look like? Kire? এরকম কোনো ভয় পাইয়ে দিস না মাঝে মাঝে আমাদেরকে। Yes, so what will the condition look like?
FNO equals to SNO or SNO equals to TNO or TNO equals to FNO.
Yeah, right. So my FNO equivalence to, if my FNO equivalence to SNO, or my FNO equivalence my TNO, or my SNO equivalence to TNO. So if if all of them are true, if rather any one of them is true, then this will not work. Then this is not supposed to work actually. So for that, I require a not condition. Right. So the Boolean laws actually say something like this, is that the A or B negation of my A or a is equivalent to, so these are my Boolean laws, please note. This gives me a negation of A and a negation of a B. Similarly, a not of a A and a B is equivalent to not of A or not of B. Right. So the other way I could have actually written it something like that also. So if FNO not equals to SNO and FNO not equals to TNO and FNO not equals to TNO, SNO not equals. So if I give something like this, so I will be having not so I don't have any repetitions. Okay. So actually, if I actually do not give this thing, then let's see what happens. So you'll see that no three of them was actually happening. So it's getting printed that no element, there is no there is one repetition for this problem. There is at least one repetition. right? So there is no money that this element, these combination of these elements are not been printed. So these are not been printed. If you actually notice. So there is no set, there is no combination which is being generated having unique elements. Okay. So okay, so this actually generates unique elements. Okay. Any other things which we can do actually?
We can use a continue statement after that if.
I will not get into that continue part. I will work with that continue and the big part later on. Okay. I'll give you some specific examples later on how to work with continue samples. Till you had any questions about these two problems? So this is one thing, and the other one was supposed to be this one. So this one. So this loop actually basically has a nested for loops, nested while loops, nested do while loops. But then you can also have combinations of all the three. So I can have a for loop, within a for loop I can have a while loop, and within a while loop I can have a do while loop. And all that depends on how you actually try to design your design your system or think of as a system. Okay, but while you're working with do whiles, please note that there is a pitfall. The pitfall is that even if the condition actually fails, it will. But initially, if there is the condition is being failed, if the condition fails in the initial stage only, then still that thing will be working out. After that, the checking will be done. Okay. Any question here? Okay. Any other problem is any others this thing programs which we can talk about, which you want? So there is some patterns problems also. There are some patterns which you have to generate. These patterns are basically these spaces. What you can see, you require some inner loops to actually, for the first pattern, you require an inner loop to generate the number of spaces. Okay. This one, there will be another loop for basically for this one. There will be another loop to generate spaces from the beginning also for this one. And then Armstrong number to basically it's something like this thing. So I have given a clue that you have to work with basically the mod operator. Modulus operator. Everybody knows what does a modulus function do?
So it gives a remainder.
It's a mathematically.
Yes,
it just mathematically gives. So mod is basically the percentage symbol is basically a mod. So this is also.
Sir, the pattern, can you show the last pattern?
Pattern ta tomade nije dekho. It's the first one. It's basically the first working with basically loops. You have to think. This one I won't show it to you. This one you have to think.
So তিনটে কি একটা প্রোগ্রামে লিখতে হবে নাকি তিনটা আলাদা আলাদা?
তিনটা আলাদা আলাদা প্রোগ্রাম, তিনটা আলাদা। তাই জন্য আমি রাইট প্রোগ্রামস লিখেছি।
ওকে
স্যার অ্যামস্ট্রং নাম্বারটা একটু ডেসক্রাইব করে দেবেন?
অ্যামস্ট্রং তোর আমি যদি কোনো নাম্বার যদি দিই, so the number is something like this. So if the sum of the cubes of the each is equal to the number itself. So যেমন একটা এক্সাম্পল 153. So 153 যদি আমি এই প্রত্যেকটা ডিজিটের যদি আমি সাম যদি করি, মানে কিউব যদি করি, কিউবের যদি সামেশন করি, তাহলে I'll get that 153 only. Okay, can anybody give me a basically logic of actually how will you oppose this 153 problem, Armstrong number problem?
So we have to so if we use the mod operator, then we can separate the individual digits from the number.
Okay,
using a while loop.
Yeah, basically, but I just want to understand how will you approach this separation of the digits. The main problem of this problem, the thing of this problem is actually separation of the digits. You will find there are lots of problems like these, like find the sum of the digits, then find the square of the sum of the digits, right? So there are lots of variations of this problem. So another thing can be what is the frequency of the digits in a number, right? So given number, what is the frequency of the digits? So if you want to, but all these sorts of problems, with actually the main requirement is we have to find out the individual digits. You have to basically separate the individual digits, right? So actually oppose the problem.
So if we divide the number by 10, then using the mod operator, we can separate every digit every time using a while loop. I mean, so we have to reassign the number after each while loop. And then like in first case 153, if we divide it by 10, the remainder is 3, and using the mod operator we can separate it, and similarly
actually there is a slight hitch with your thing, but I want to think of the general way. So you are actually thinking of 3-digit problem, right? So if I think of a 2-digit problem, so it's between 1 to 500. So if I give you 23, then how about 2-digit?
Sir, if we like divide the number, we are dividing every time by 10, and until the number is greater than 0, the while loop will run till that time. Otherwise, it will.
Yes, the logic is right, but can you give me the steps actually?
Sir, actually, first we have to know the base of it. It is possible with any base number. Like now we are working with decimal, so its base is 10. So when we have a number, say it is any number. So if we divide with its base, the quotient is the quotient. There is a quotient and there is a remainder. So the remainder is the last digit and the quotient is the remaining digit. So in this way we can cut the digits.
Okay, fine enough. So you have basically found out the last digit, right? So you're going from your right hand side to your left hand side, right? Now basically you have got your last digit, that is a 3. Now you want to extract 5. How will you do that?
So we'll repeat the same step.
Actually we'll divide it by 100.
Yeah.
Then
you'll divide it by
100. Then the percentage 100.
Are you sure you want to divide it by 100? So your problem will be specific of basically working with only 3 digits. So if I give you a number, if I arbitrarily run it between, find out all the Armstrong between for all the numbers ranging from a single digit to let's take for example 6-digit number. Okay, so how will you do that then?
So we have to use the base of the number system we are using.
Yeah, I get that. So you got some base of your, so you're finding out the mod operator, you have found out your basically your third digit, last digit, right? Because you're starting from your right hand side, you have found out your last digit. Now you want to find out your second last digit. How will you do that?
So we will continue the step till the number reaches 0.
How will you do that? That's my that is.
So if we reassign the number with the new number, I mean after 153, if we divide the number by 10, we will get 15 and the remainder as 3. So if we reassign, you are actually right, but I want you to basically, I want to know how you're going to do it. So we will create a copy of the number in the original step.
What is the logic behind that? So basically 153 divided by 10, you are saying that will give you a 15. Why?
So it's
I'll just ask a question. Do you think that basically this will work for real numbers? Will your logic?
No. I'm only talking about integers.
Yeah. So your main thing is that basically your main objective is that, or rather your main assumption is that all of them are of integer data types.
Yeah.
Right? So that is where you start from. So they are all integer data types. So obviously 150 is divided by 10, which are both integer numbers, and you actually assign it to another integer, it will give you a 50. It will not give you 15 points. So that's how you work it out. So you must, when you are thinking of a problem, when you think of a problem, when you try, never skip steps. Never skip steps, because the what you are thinking, right? What you are thinking aloud, that is what you're going to reflect. That is what is going to be reflected on your program, right? Because this is not mathematics. I mean, there's a little bit difference between mathematics and a computer program. For a computer program, a computer is actually, believe me, when I think of a computer, is basically an ass. It's a donkey, right? Who can actually, but the advantage of your donkey is that it will work of your instructions. So if you skip one step, if you skip one step to your donkey, right? He will also skip it, and he will do something very something which is not required. So if you basically take your donkey towards a cliff and tell him to jump, he will jump. So, but if you give him a check that, okay, if you see a cliff, then step back. Then that is what he's supposed to do. So never skip steps while you are working with basically programs. It's very important. Or rather, when you're thinking of basically solving a problem with a program, because once you skip it, it will be reflected in your problem. Okay.
Yes, sir.
Okay. So this thing, we have got into nested loops. We have got into this thing. So let's get something like this. So today I'll pick up a problem, something like this. So find out the frequencies of digits, lengths, and other non-digit characters for typed through the keyboard. So this is what my problem is. Just can you please excuse me, please? Just So for basically working with this sort of a problem, what can we do from actually what we have learned right now till date? So what can we do? Anybody? What we will be doing?
Sir, I have an idea. Can I say?
Yeah.
Sir,
If we take the input we take in a variable and we then change the variable to char, and then we if else if, and then the ASCII codes, if we match with the ASCII codes,
Mhm.
and then if it lies between the digits ASCII code from this to this, then it's a digit, then digit plus plus, and then else if
But
for
then,
blank.
but that is what I'm asking. Basically, this is I'm looking for the frequency, right? So if I'm looking for the frequency, then I require to keep keep the information in some variables, right? So for this
So
problem, how many variables I will be requiring?
256 variables.
256 and
3 variables for each.
3 variables. So blanks will be requiring another variable. So and other non-digit characters. So other non-digit characters you only one variable, right? And for a digit variables are requiring 10 variables, right? Right. So 0 to 9 I require 10 variables. 11th variable will be for the blank, and the 12th variable I will be looking for the non-digit characters, right? Am I clear a little bit?
স্যার প্রত্যেকটা ডিজিটের আলাদা আলাদা ফ্রিকোয়েন্সি স্টোর করতে হবে
তাই তো বললাম
আচ্ছা
of the individual digits. Sorry. So this looks like something like that. Okay. Okay. So let's go for something like this. For std.h. Include. std.h. Underscore success. So I can think of something like this. So int so n1 is basically first number, n2, n3, n4, n5, n6, n7, n8, n9, n10, blank, n one digit. Okay, so I go on checking for each numbers, one of the most basic ones. So if so I give a while char, I can give char is basically ch, while ch is to get char. Is not equals to f. Right. So I can basically work with this. So I read each character, and based on each character, if it is there, then I can basically work with this thing. Okay. The problem is that if I actually do this stuff, then the system becomes very, very complex, right? So what I'll do is something like this. I'm going to stuff these. Now these are what are these are actually numbers, right? So 0 to 9, these are numbers. So what I can do is that basically I can actually basically categorize these whole stuffs as one block, as one system, which I'm saying that which a system which actually basically thinks of them, each of them has to be as frequencies, right? Now if I were to do that, then I can think of them easy even them as boxes also. So creating a set of evenly matched system, evenly matched basically character, which but if some variables which has got same characteristics, I can actually basically form them to be as one block, and that block to be as a array. So number 10. So an array will be defined as array is basically defined as the data type, variable name, within the braces, the number of the number of boxes. You can actually think of something like this. So within these bases, this is my data type. So if I actually see this thing, for example, so int, right? So int will be my data type. Variable number is basically number, and this is the total number of boxes which I've got, right? Each of these elements can be basically accessed by I'm going to access each of these variables, right? So you can think of these are also variables, but then all these variables basically has got let's say basically frequency number. So this variable, what has got each of the characters? So all my boxes will be basically denoted with something like that for the characteristics that they are basically frequency of a number. So my array will be basically accessed with something like this. F number 0. It starts from a 0 always. Please remember. F number 1. Then dot. It goes up to F number 9. So the total allocation, it's basically starts from a 0 to the total number of boxes minus 1. Right. So this becomes this is equivalent to, I can say, as I was basically saying that NO0, NO1, NO3, NO2, and dot to NO9. That is previously what I had done. Okay, so instead of all these 10 variables which I'm not going to do, I'm going to basically make my life a little bit easier, and so it becomes a variables variable name with a number of boxes. Now these numbers which you see, these 9, 1, 0, right? So let's take, for example, if I want to basically access so when I'm actually basically creating this initialization variable, so the numbers which are actually over there, they are random numbers, so I do not know what they contain. So I can actually basically start off with, so I can have a loop, right? Loop counter. So for loop, equals to 0, loop loop less than 10, right? So 10 basically gives me 10. So loop plus plus, then if number loop equals to 0. Right. So what is happening right now is that by each of these, so you can see that with only one single line, I can actually basically two lines of code, I can actually basically access the whole loop, or rather I can access all the f numbers, right? So if I give something, I can even initialize with loop. So so what we'll actually see, what's going to actually see for again printf %d space comma if number loop. So you can see this thing, this part, this number which is there, this is actually a variable. This works like a variable, right? So let's see what it can actually look like on GCC. See? So my first number 16 to 17 was basically initializing my each of these which of these array elements. So these f number loop is basically each of these array elements, right? So this is a loop. Each of these f number 0, f number 1, these are my array elements. So if I had initialized each of my array elements with a loop, with the integer, since it's an integer variable only, so my data type being an integer, so I'm actually initializing with an integer in one way, right? I'm basically like 19 to 20, and I'm basically printing the whole loop. Any question in this loop part? I can have loops of all my data types. I can have loops of any of my data types. I can have a loop of, I can have an array, sorry, I can have arrays of any data type. I can have arrays of 10 characters. I can have arrays of integers. I can have arrays of floats. I can have arrays of long doubles, long ints. I can have arrays of doubles, anything which you can think of. Okay, so so now I'm going to find my frequency, right? So while this thing will work something like this, as ch equivalent to get card is not equals to uf. Right. Now I'm going to check. So putcat, I'm going to give my putcat ch. Now my condition starts, right? So if so my each of these digits will be basically between 0 to 9, right? So this one will keep all my frequency to 0 to 9. So if ch is greater than equal to a 0 and ch is less than equals to 9. So 9 is basically character. Right. Then my if number what is the ASCII code of 0? What is the ASCII code of 0?
48. 48.
So minus 48 plus plus else if ch equivalent to a space then blnk plus plus. So my also will be initialized to 0. My non-digit will be also initialized to 0. My loop will come over here because all initializes comes as last, right? Else non-digit plus plus. So printf. So I require again my for. So I can be I require basically how to print all these things. So for loop equals to 0, loop less than equals to 9. So less than 10, so let's say for example, loop plus plus printf the frequency of percentage d is percentage d. So slash n. I have got a loop with f number loop. So my printf so I can just basically of length is
Sir, sir, in the first if condition, you have written if number of 0 minus 48 plus plus. Sir, would it be if number of ch minus 48?
Sorry. My mistake. Okay. So let's see what it actually looks like. So 1, 2, 1, 3, 4, 5, 6. Space. 7%. 4, 5, 5, 5, 9, 6. Exclamation. Enter. So I've given an enter over here. WERTY. Yeah.
Sir, f number of loop will be 0 in the first for loop. In the only for in the first.
Yeah. Sorry, this one will be 0. Sorry. So 1, 1, 2, 5, 5, 6. E space B T 9 5 exclamation dot 1 enter GH 4 5 6 7 to 2. second enter control T. Yeah. So the number of non-digit characters are blank. So GE, these things are actually non-digit characters. Okay. Any question?
So why did you put
Sir, I
that
was
f number loop equal to 0?
I was initialization. Okay, this is actually a misnomer over here. Some actual literature says that there is some literature which actually says that, right? So when I'm actually basically working with f numbers, so it will be giving some random numbers. It can be anything random, right? So you can actually give this thing there you are not, if you're not very sure of what this thing will be basically working out. So let's take for example 1 2 3 4 5 6 7 8 20. See, I did not initialize it. So my frequency, there is no ones you can actually see. There is a, so but it has been actually initialized with some random numbers. It has been initialized with some random numbers. So for a loop, if you create any loop, so the contents of that loop, if you do not initialize it, they will be basically initialized with some random numbers. Now, this is again dependent on OS to OS. Right, this depends on OS to OS. So there is a misnomer that there is some saying that some books say that it will be initialized with 0. Some books say that it is not initialized with 0. But then the thing is that you do not know actually. Bet is basically to actually initialize your array elements with something which you actually require. Okay.
Sir.
Yeah.
Sir, in line number 34, will the non-digit variable show only the non-digit, show the frequency of only non-digit characters, or it will show that blanks also?
No, it will not consider blanks. The frequency of okay, this thing is basically non-digit to non-digit. Okay, you can see that excluding. Because I'm not actually basically, see, my non-digit is basically what it is counting. So if this is the blank, this is going to be a blank. It is going to basically increase my blank. But then this statement, what will happen when it will actually work out? If this is false and also this is false. So my numbers and my blanks have actually already been basically they have already been accessed with, or they have already been considered with. So any other character or it's not a number will be considered to be as a non-digit. Okay.
Yes, sir.
Sir,
what was the significance
happening
of
in
line 24?
Line number
I'm
24.
also asking that.
Okay, this one. Okay, this thing is a fun part. So this is the fun part. So let's take for assuming let's say my CH is basically 7, right? So my CH, so my number is basically like this. So ASCII codes. ASCII codes. So my 0 is basically, this is 0 is a 97, right? Is it a 97?
48.
48.
So 48, right? So 1 is actually 49. 2 will be sorry, 49, 50, and dot. So what will be my 9? 9 will be my
57.
Huh?
57.
57, right? So let's see. So let's assume my character is basically my character input is actually 2, right? So now what, this is a character. Now my character, I'm basically in my character, when it actually basically working, I can make my character, any character, to be also working as an integer. So what will be, integer will lie between a 0 to 55. Any character you give any character, right? So that character has got a corresponding ASCII code. That corresponding is got an ASCII code. So my character can be also be it can also, you can think of it as a character. F number 2. So F number 2, I have already initialized my value with the F number, all my F loops with the F number elements to be as 0. So this one, what is going to happen is that I'm going to actually increase that value of that element. Actually happening. I'm actually in this line. I'm actually you can see that you can think of this character to be an integer, which is an ASCII code. Equivalent code is basically 50. So 50 now it becomes 50 minus 48. Right. So over here, when it does that checking, this behaves like a character. But whenever there is a multiplication, or whenever I'm basically whenever I'm doing some manipulation with some integer number, my CH behaves like a, or that is an integer also. So this is basically what is happening. So CH, so if my character is basically 48, so 48 minus 48 will become a 0. So I'm actually accessing the element of F number 0. I'm accessing the element or the variable, you can even think of like that. They're accessing the element variable corresponding to F number 0, and I'm actually increasing that variable's number. So with that, this is with the plus plus. This is what I'm actually doing.
Sir,
yeah.
In the if condition, CH is a character and you are using it as a mathematical operation to check if it is greater than equal to another character. What is the significance of this thing?
Okay, for this part for line number 28 or for the line number 25, right? When I'm actually doing it equivalent to a basically a blank character or a 0 or a 9, I'm actually correspondingly checking it with the characters. So right now this behaves like a character, but is a mathematical operator, right? This is a mathematical operator because you cannot do it with any sort of any other element. You cannot do it with a character element. So you cannot basically say that this character is my number is my character to be greater than another character. You can't say something there. So whenever this mathematical operator is working over here, so what it actually does, it checks the ASCII code of CH with the ASCII code of 0. Right. So this one is this line, you can actually say this is equivalent to this is equivalent to children. And I can also think of this thing something like this. So when I give a in CH, right? So in CH, when I'm going to read this character get CH, what is happening? A character is being read, the ASCII code of which is basically being kept over here. So you can think something like this. Okay, so let's take for example, if I actually do not give a this thing printf, percentage C equal to percentage D CH, comma CH, so percentage N. So you can see that C, character C, so this CH is behaving like a character point per percentage C as a character, and then also as an integer also, right? So let's see what happens over here. So,
Sir, it will be printf.
oh, sorry, printf. Okay, so Q, see, the ASCII code of Q is basically 113, but then there is an enter also, which I've given, right? Because with each printf, I have to actually basically give a enter. So whenever I'm giving an enter, the ASCII code of enter is also going to come. So there are two characters which are coming in. So in what way, what is actually happening? I'm reading the character, I'm given an enter, right? My system has got what we see as a buffer, right? So that buffer, whenever it basically reads that character, it also reads that one integer, one character, that enter also. So what is happening with each printf, these two things are actually being printed at the same time. So if I give a, see, if I give a 0, so every time with an enter, this zeros equivalent to the entered is basically the ASCII code of enter is actually 10. So that's
how can we remove that enter?
Okay.
Sir, in the else condition,
yeah.
Sir, if we write else if and then check the character ASCII code not equals to the enter keys ASCII code, like not equals to 10, then not. Sir, in the else part, if we check that else if ch not equals to 10, then it will check whether the enter keys ASCII code.
No. This effect, what you see, this effect, this is due to the printf. This checking part comes later on. So you're printing something immediately, no? You're printing something immediately. So what is happening is that when I'm getting a ch with a get cat, I'm entering the data and I'm giving an enter also. Right, because of that thing, enter is basically that thing is going. See, okay, this thing is actually being printed. Okay, this thing. Control D. Yeah. So my printf is working over here. My printfs are working. So I've given an enter, which is a 0, 10, and then this is happening. So enter is actually basically also considered to be as a non-character. Are you getting it? So with each enter, since that enter is also a get carrying, the enter is also getting a get car, right? So that is also being printed with the ASCII code also, with the previous one. Okay, I mistake my previous one with the scanf. Okay, so with the scanf, we have to basically give an enter. So that is why this was actually my mistake for this thing. Okay, so you can see with each character, the ASCII code is also coming. So with a 0 is a 48. So this is what is happening in line number 24. So 48 minus 48. So this CH, I can basically make it behave like a char also or like an integer also at the same time. It is according to my own thing. So if I had given something like this also, this would have worked. Sorry, 59. So you can see in my line number 23, my first part is basically my CH is behaving like a character. Is basically character 0, but then since my less than greater than equal to is there, so this greater than equal to is my mathematical operator. Since this is a mathematical operator, my CH will then behave like an integer, and this zero will also behave like an integer. So even if I give this one as a char or an int, CH, so considering that the input is get. So this is the main thing. So char CH and int char CH, right? They are the same thing. The considering is basically the input is to get char. Now, if I do it with a scanf, then the system will not work. Then the system will not work. Okay. Any question? Any question here? Any question here? So since there is no question, so I'll just I'll keep these lines for your own reference. So I'll just remove this part, and I can even basically check it with Bonarchy for this thing also for my statements. Return RET RN is equal to 0. Right. So again, if I can give something like this, else if ch equivalent to /n. So /n is basically my return statement. So retrn plus plus
So if you are declaring ch as an int, then when you are printing that character C is that equivalent character means the line which you have put it into comments now. That
which
line.
Line number
22.
Okay.
So in that the ch is int. So while printing it as a C means as a character, won't it create a problem?
No, because it's a character.
No, you are taking input. If you are taking input as a
So
int,
you're talking something like this, right? What this will happen?
Yes.
This thing. No, it will not do, because what will actually do is basically now ch is a get char,
Yes.
right? When it's basically saved into a ch, the variable which is an input is actually being saved, not the character.
Okay, sir.
Okay, so this thing, the ASCII code is saved into ch when input is 3 get and so now let's do one thing. So you just remember that both of them are actually equivalent. Right. So if it is basically my ch is basically an enter, then we'll check it as a new line. My returns will actually basically monarchy will actually increase. Any question till here?
Sir, sir, instead of /n, if we write 10, will it not work?
/n 10. Okay,
Yes,
you want
sir.
to check basically 10. Okay, the thing is,
Yes,
okay,
sir.
there is
In
certain,
line number 29.
it should work actually. It should work. I believe so. It should work. It should work. So let's see. This thing, okay. I'll take your suggestion. Let's see. Let's see what happens. So 3 TDF 5. So there is another enter. Control T. So it's giving your 2. Yeah, it's okay. It works. It works. Okay. So this is again just a note. Equivalent to basically ch equivalent to /n. Okay. Okay. Any question till here? Actually, this is a starting problem of loop. Afterwards, I'll be getting into a lot of loops right now. So if you have any questions from these loops, please get into it. So there is no there is nothing like that, right?
No, sir. No, sir.
Let's see. Anybody is chatting up with any problems? Ritam Brother, I told you in the beginning only, I'm not going to see the chats because it's not possible for me. While I'm working in the class, it's not possible for me. This is an online class. It's not an it's not a this theoretical class, onboard class. In the onboard
Sir,
class,
যেখানে ch equal to get কা not equal to end of file দিচ্ছেন ওখানে স্যার দুবারই কেন আমরা ইনপুট নিচ্ছি ওর বেশিবার কেন ইনপুট নেওয়া যাচ্ছে
কোথায় রে?
স্যার ওই while লুপে যখন দিয়েছেন না তখন ওখানে দুবারই আমরা ইনপুট কেন মানে দিচ্ছি?
দুবারই কোথায় ইনপুট দিচ্ছি রে?
স্যার না আপনি দিলেন না ফার্স্ট একটা নাম্বার দিলেন তারপরে দিলেন QWERTY ওইটা মানে দুবার দিলাম তো। পুটক্যাট তো ওটা ডিসপ্লে করছে।
পুটক্যাটটা বেসিক্যালি ওকে যখনই when I'm actually given enter না on the end of file what is happening is basically 2 times মানে by default মানে the buffer look every the system has got something like a buffer. Okay, so everything is actually put into the buffer, right? So whenever you basically when my enter or my this thing what does my buffer create? My buffer is basically assigned by the operating system whenever the process starts. So it's a finite buffer. It's not an infinite buffer, right? So whenever I'm going to basically give inside the data is being kept in the buffer. So what is happening whenever the enter is basically given, right, or the control D is being given, it prints that whole buffer. Once it prints that whole buffer, that buffer is again cleared. So you can see that is why you can see that it's 1, 2, 3 DDF and not basically the second when I'm giving the enter over here, this thing over here after 2, 2, 3, 4, you don't see that basically 1, 2, 3 DDF is again being printed. Actually the buffers gets cleared up. There is also
2, 3, 4 এর পর তো প্রিন্ট করে দিচ্ছে যে 0 কত 1 কত তারপরে কেন
না 2, 3, 4 এর পর আমি একটা এন্টার মেরেছিলাম। আমি একটা এন্টার দিয়েছিলাম 2, 3, 4 এর পরে।
হ্যাঁ 2, 3, 4 এর পর এন্টার দিলেন তো তারপর আবার কেন আমরা আরো মানে ইনপুট দিতে পারছি না সেটাই স্যার জিজ্ঞেস করছি।
আমি তো কন্ট্রোল ডি প্রেস করে দিয়েছি।
ও কন্ট্রোল ডি ও ঠিক আছে স্যার।
আচ্ছা সরি মানে I forgot to mention I'm pressing control D. And after this control enter I'm pressing a control D. I'm pressing a control D over here. Okay.
Yes sir.
Okay. So since there are no questions, we'll finish up this part over here only. Right?
Sir.
Yeah.
Sir, F number CH minus 48 plus ওটা ওই পার্টটা একটু আরেকবার এক্সপ্লেন করুন ওটা।
Okay. That let's see what this basically my CH has. Basically CH is basically a character type, right? Okay. Now you are entering let's take for example 1, right? Putcat is basically you have entered getcat you have entered a character 1. Now when this CH is being initialized with this 1, it is a character, it is behaving like a character. It is behaving like a character. Now all characters, if you actually see, they have all gotten ASCII codes. These ASCII codes are simple integers ranging from 0 to 255. So in one way what is happening is that my CH can, since it is a single character and is ranging from 0 to 255, the ASCII code is being written, so that CH can behave both as an integer and a character at the same time. It can behave like a character or the integers at the same time, right? So over here in the CH greater than equal to তোমার যখন এটা যখন হচ্ছে তখন এইখানে যে CH টা যেটা হচ্ছে the CH, right, it's a character. The character which is at 1 is being checked with a whether is being checked with a is greater than equal to 0. That now the problem is that greater than equal to কি এটাতে একটা শুধু ইন্টিজারের সঙ্গেই কাজ করতে পারে, it can only work with a number, right? Greater than equal to, less than equal to, equivalent to, not equivalent to even works with this thing. Then equivalent to also, then there is a not equal to. So these works with only integers. It works with only integers, right? Now these integers, so over here what is actually happening, CH when I'm giving a 1, that its ASCII code becomes 49. So it checks that 49 greater than equal to 48. It does not check the character part right now because আমি এখানে কিন্তু already কিন্তু একটা I have given a mathematical operator over here. So the check is right now is greater than equal to 48. Yes. Similarly over here, now what is actually happening for this part, I'm actually checking with an integer itself. equivalent of 9. Now over here, what is going to do is that now my CH is again an ASCII code, right? So it's going to check 49, is 49 less than equal to 59? This one is also yes. Now if this both are yes, this is going to come to this line 26. Now in this 26, what is actually happening? This is CH. CH is basically 49. Current number CH is 1. It evaluates this expression. So 49. Okay, I can actually basically write it something like this also. Let's say this thing also. If I actually basically, this one might become much more easier for you to understand. So I take another variable diff, right? So diff equals to ch minus 48. And I give a diff for it. So I'm assigning a variable, the ch. What is ch? Ch is an ASCII, is a character, right? It's basically one character. Now over here, this is a minus symbol, which is a mathematical operator. So right now my ch will right now behave equivalent ASCII code will come up. So which is 49 of 1. So 49 minus 1, 49 minus 48 becomes the diff becomes 1. Now this diff, this is a variable. So I can actually access each of the array elements with a variable. So diff. So this is a diff. So f number, this becomes a 1. So f number 1. So for the array element f number, I am checking the first element for second element, that is 1, because my array element starts to a n minus 1. That is a total, where n is a total number of array elements, right? So this one will becomes a 1 over here. Now if my ch is a 0, then my diff will become a 0. So f number 0. So f number 0. So f number 0. What does the value of f number 0 works? What does f number 0 is? F number 0 is basically a 0, the frequency of the f number element, 0th element. That is what I had actually worked with.
Okay, sir, got it.
Okay. But basically this thing, this is equivalent to basically, I can say this is the same thing as this thing. This one, this is again equivalent to right. Same thing. All means the same thing. All means the same thing. Both of them means the same thing. Any other question? Any other question?
No, sir.
Okay. Then we will end this class today for this thing.
Thank you, sir.
Okay.
Thank you.
Please write your program before you assign, submitting all the assignments.
Thank you, sir.
Okay. The assignments, again, I'm telling you, this is for your own help. Okay. For actually helping you to work with it. Okay.
Sir, the assignments we have to write in Google Documents or in a C programming, whatever it is called, in Visual Studio or something.
What that depends on what sort of ID you actually using. As you can see, I'm using a simple text. This gedit, and I'm simply using a GCC compiler.
No, sir. I'm asking that whether we have to upload that screenshot of that program, or we have to write it entirely in a different clean page or
If you
something.
actually the patterns I'll be asking for, basically it is preferred that you actually give the screenshots for the patterns. For the other parts, it's all right. If you given it, it's all right. You can basically give it. Okay.
Okay, sir.
But then everything you can put it in all in the Google document, that document. Okay.
How
Yes,
do
sir.
we take,
Thank you, sir.
String input here.
Yes.
How do we take string inputs like set of?
I'm not got into strings. I'll come to later on. Do not leaps. Do not start making leaps.
Okay.
যে কটা দিয়েছি সেই কটা কর আপাতত। Yes, sir. चलो then.
Okay, sir.
Okay.
Thank you, sir.
Thank you, sir.